Welcome to chemistry lesson number 8, part 2. We are talking about types of reactions. Today, under that, part 2 is double displacement reactions, DD. Now, in these reactions, two solutions, we are mixing two solutions, A, B, and C, D, and we are getting A, D, and C, B as products. What is the reason for this order? Now we know that when we write a compound like this AB, A is the positive ion, B is the negative ion. We write the positive ion first always. C is positive, D is negative. Therefore our products will be positive with negative and positive with negative. So that is A, D and C, B. And in this reaction, one of the products is either a gas or solid. Other three are aqueous, that means dissolved in water. So we have the compound AB dissolved in water, that's what we call aqueous. CD dissolved in water, and one of the products AD also dissolved in water, aqueous. In lesson number 7, we saw that a soluble compound, when it is dissolved in water, it breaks into two ions. They are free to move around in the water. They are swimming around in the water freely. Let me explain this one using some real life situation. Now I have colored two ions in red color. Just like two people are coming to a swimming pool and one of them is a bit lazy. Again, two people coming from one family, one of them is too lazy to swim. So when they see the real partner, what they do is they get out of the swimming pool and start talking. Sit down somewhere and start talking. See what is happening? Sodium chloride, silver nitrate, two solutions. You get sodium nitrate and AgCl solid. So they are now out of the swimming pool. They just sit down and talk. They are solid now. They are not swimming in the water anymore. So this is how I used to explain this. So when the correct lazy person see the correct person, they get out of the swimming pool. To understand which two ions are doing it, we have something called solubility rules. If you have a compound of chloride, bromide, iodide, they will make a solid with these ions. See, I have colored them in red in the ions that I have in my example. Chloride. If chloride ion sees the silver ion, they will become a solid. Not only that, these three will make solids with these three separately. In the same way, you have to learn this table. Sulfate will make solids with these ions. Silver ion, lead, mercury, and strontium, barium, calcium also. Carbonate and phosphate make solids all the time except with these three ions. Lithium, sodium, potassium and ammonium, these four ions. Hydroxide and sulfide will make ions almost all the time except with these ions. Nitrate, acetate will never make a solid. They are always soluble. These ions are always soluble. So it's a good chart to memorize. Now in our example, We saw that sodium chloride react with silver nitrate, giving these two compounds. Now we said that they are freely moving in the solution in water. So actually we can separate them. See the sodium ion aqueous, comma chloride ion. Same thing with this one. Same thing with this one. So that's why we talk about the total ionic equation. This is the total chemical equation. This is the total. We are going to see the total ionic equation. So now you can see that sodium ion was in the solution at the beginning. Even after that, after the reaction, sodium ion is moving around in the solution. So nothing happened to the sodium ion. Same thing with the nitrate ion. We can cancel them. So actually what was happening was chloride ion in this solution react with silver ion in this solution. Both of them are colorless and they join together and make the silver chloride solid. It's a white color solid. So this is called the net ionic equation. Let's take another example. Reaction of magnesium bromide with potassium phosphate. If they ask what is the word equation, total chemical equation, net ionic equation, total balanced chemical equation, this is how we start the procedure. Our two compounds are magnesium bromide and potassium phosphate. So first we have to make their chemical formula. Magnesium bromide. You know magnesium is in group 2, so it is making ion Mg2+. If you can remember lesson number 1, 2, 3, we'll remember this. Bromide ion, Br-. So we use the Crisscross rule to make the formula. Mg, we write Mg, we write Br, and then this 2 comes down here. So the formula is MgBr2. Potassium phosphate. Group 1, K+. Plus 1 we don't write 1, we just K+. Phosphate ion, we can remember phosphate ion in previous lessons. PO4 charge 3-. So let's do the crisscross rule. We write K here, PO4 here, charge 3 going there. Charge 1, we don't write 1, so it is K3PO4. Now we can start writing the chemical equation. Skeletal chemical equation. So MgBr2 and potassium phosphate will react. Now we can predict the products. One product is KBr. We know the formula is KBr because K is +1 charge, Br -1 charge. So we know that's KBr. Other product will be magnesium phosphate. How do we know that it has this formula? Magnesium 2+, phosphate 3-. So again the crisscross rule will show you that MgPO4, 2 is going there down here, 3 is going down here. So this is our magnesium phosphate formula. Now we have the formulas. It's called the skeletal chemical equation. We can write a word equation now. Magnesium bromide plus potassium phosphate give you potassium bromide and magnesium phosphate. So that is our word equation. So I have written this again. Now we are going to balance this one. How do we balance this reaction? You have to inspect, you have to see what is happening. You can see here you have Mg3 here, 3 magnesium atoms, so 3 magnesium ions. So you can quickly put 3 in front of magnesium bromide here. Now we have that 3 there. And then look at the bromide ions. So when you put 3 here, total bromide ions become 6. 3 times 2, 6. So in the next step you can put 6 here. What is the next step? When you put 6 there, number of potassium ions becomes 6. Therefore you put 2 here, so that 2 times 3, 6. Now you will see that automatically your phosphate ions are balanced. PO4, 2 of them, PO4, 2 of them. So now we have the final balanced chemical equation. Now we can finally put the state symbols. State symbols. Aqueous, dissolved in water, aqueous, aqueous, and this white color solid again. White color solid. And now we are going to see the net ionic equation of that. Net ionic equation. I wrote it again here. Now we can break down into ions. They are dissolved in water, they are swimming around in the water freely. So 3 magnesium ions, aqueous, 6 bromide ions. So I drew that in red color for this compound here. 6 potassium ions, 2 phosphate ions. I drew that in blue color. So they are here. Now we are going to mix them together. Then we get 6 potassium ions, 6 bromide ions, and this solid. Since it is a solid, we cannot break them because they are together. Now as before, our bromide ions were at the beginning, at the end. Potassium ions were not doing anything. So our final net ionic equation is this plus this give you this. So we can only write those 3. That is our net ionic equation. You can try this by yourself. Write the word equation, skeletal chemical equation, balanced chemical equation, net ionic equation for this reaction. That is when you mix aluminum sulfate and sodium hydroxide. If you can even pause and try. You can pause now and try. If you do it properly, hope you pause. You should get the net ionic equation like this. 2 aluminum ions with 6 hydroxides ions will give you 2 aluminum hydroxide. And that will be your answer. Thank you for watching.